It's Gadget UK here again. This time we have an Atari ST on the carpet here. This was donated by this great guy here. My memory's useless. I know that I did a live stream recently, and I think he joined the live stream, and when I showed the box this was in, he mentioned it was him that had sent it. You can see a little crack there, so I think that's been previously glued. He did say he'd fixed something in here, a piece of plastic or something that got broken, so maybe it was that, or maybe it was another part. But if we just turn this up, could you hear it? There's something loose inside, a bit of plastic or something. So let's have a look around it. So on the top side of it, there's only that little mark there that I can find. It's still got the original floppy drive there. There's no damage on that side. Everything looks fine on the back here. And I guess while we're here, may as well cover these ports. Oh, there is the crack there, can you see that? Yeah, so it's not quite as damage free as it appears. There is a crack there. I thought it was a hair or something, but no, it's not. So we've got a modem here, which is, you know, your serial port basically. Parallel port, hard disk interface, external floppy disk. It's a huge connector, that. RF modulator, and your monitor output. So you can get like high-res monochrome out of these, or, you know, RGB you can get out of there. Probably composite as well, definitely. Power switch, IEC, you know, power socket there, and a reset button. So on this side here, you've got the MIDI ports there, MIDI out, MIDI in, and a cartridge port there. I do have a cartridge you can use to test this in a bit. It's interesting, I never noticed there's kind of like a cutout there moulded into this, as if they designed originally something to go there. I never noticed that on any of the other STs I've looked at. And on the underside here we've got the infamous location here for the mouse and joystick ports. So you can see that first one there, it's got a mouse symbol and a joystick and a joystick. Quite nice those, I quite like that style there, having these little icons. So if we get all the screws out, let's have a look inside it before I power it on. I'm interested to see what the rattling around is inside there. The screws that go along the back here, they're slightly longer. Can you see? That's one of the ones from the back. That's one of the three from the front. So you've got to bear that in mind, that they're different size screws in different places. This should be the final screw that holds the lid on there. So let's see if the lid will come off now. I think I have got all the screws out. You've got to kind of lift it from the left hand side there and pull it over the floppy drive thing like that. There you go, and then it comes off. So yeah, I can see the points where he has glued it. So this was where the damage was on the other side. Has it held it in place? Yeah, it probably has actually. It's not too bad that. That could have been a lot worse, so he's done a good job of fixing that. So the keyboard's pretty yellowed on this. I might retrobite the keys. I wouldn't go as far as retrobiting the case. They've got a nice kind of green colour they go, actually, I quite like. Anyway, let's just disconnect this here. Looks like it's been upgraded, this. Can you see? There's a little board in here. So, and it's the rarer board actually. I'm glad that I've got this particular one. It's got a different type of RAM on here. It's still DRAM, but the types of the chip, it's like a square chip with connections on all four sides, and they're really small, and there's quite a lot of them. So that would perhaps explain why it's got this third-party memory expansion on here. So the next thing we need to do is remove all the screws around the shielding here that hold the shielding down. You know, hold the motherboard down effectively into the shell there. There are quite a few different revisions of the Atari ST. You know, you've got like, I don't know, I think there's a standard ST, STF, STFM. The F stands for floppy drive, the M part is for modulator. So some of them didn't have a modulator, some of them didn't have a floppy drive. The original ones didn't have a floppy drive. I think they only had like 256K as well. And I think the very early ones, you used to have to boot TOS off a floppy disk, just like you did on the Amiga 1000, where you wanted to boot, wasn't built into a ROM. You know, Kickstart wasn't in a ROM originally. You had to boot a disk, and the operating system would then be stored in RAM instead of ROM. So the shielding comes off just like any of the other STs really there for the power supply. So that cap's looking a bit weird there as well. Can you see that? You also get these little twists here that Atari are infamous for. Really, all of their products have them. You know, they go all the way around the edge here. You've got to kind of straighten them up so that they fit within the profile of the gap of the thing there. So once you've got all the screws out, it'll come out. We need to get the screws out from underneath the floppy drive as well to get the board out, and there's also a little cover here with a screw on each side. Often these get lost actually. It's surprising this one's still on here. Yeah, there's the 3 floppy drive screws. This particular one appears to have an Epson floppy drive, which were quite common. A lot of these ships with Epson units. So we can disconnect the floppy drive. Good God, that's well and truly stuck on there. That was incredibly tight. So we've got a couple more screws at the back here. You can see that brass mount for the floppy drive here. That's why they only have three screws, but they have a mount for the 4th point on the floppy drive there. I always thought it was a bit weird. And another screw there. And it's been a while since I've been in these. I realise now that the 2 screws hold the power supply in. It's very common for the power supplies in these to need recapping. Generally, I would just replace the caps certainly on the secondary side here anyway. So you can get the power supply out without taking the board out, but it's kind of like a wrestle thing where you've got to pull the back away a little bit here, try and lift this up, and then the front. You see, you've got these 2 things here that are screwed, that were screwed in. Those just sit flat. The ones on the front, the 2 front ones, they've got like little flat bits that go over like that through the gap in the PCB. So yeah, it can be a little bit of a challenge. Sometimes you've got to kind of, pull the back away here and lift it upwards a bit like that in order to get the power supply out. Don't forget to disconnect here as well. That should now hopefully free up the power supply. There we go. So you can see it's got 2 ROM chips, and we've got space for 6. Got 2 more screws over here. Look, it's incredible how many screws and stuff there are related to the shielding and stuff. They're really well built, these. Got another one of those little twists back there. I don't think anyone's been in this since it was upgraded. So, it could literally be 20 odd years ago since someone's been inside the motherboard part of this. Anyway, let's just get the shield off. There you go. Lifts off like that. And there we go. You can see what I mean now about this being quite a rare version. Look at these small little ICs here, like say with pins all the way around them. So those can be quite hard to find spares for. You can get that chip, these chips here, off some of the old Sims. You get like a 256k Sim, and it'll probably have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. You probably get a 256k Sim, and it'll have 8 of those on there. So that's one route to be able to, upgrade one of these. But yeah, it's a bit fiddly soldering those on. They're kind of like those SOJ ones, aren't they? They're a pain in the bum to solder on. So it's curious how this cap is here like this with this extended wire. I'm not sure it would have originally been like that, if I'm honest. Maybe someone's done that. Yeah, I think they've done that so they can fit this here. It probably would have been soldered in down here somewhere, and they've just done this modification to allow this here to fit. I'm guessing the MMU is somewhere here. Let's just tilt it up a bit to see what's under it. Yeah, here's the MMU. You can see that. Look at it glued on. That's crazy, absolutely crazy. So I mean, I'm not going to interfere with that at this stage. We'll go and test it. So looking at the chips there, those look like the chips you get on an A500. So you'd have 4 of them to give you a meg. Now I'm guessing this has got half a meg here. So unless this is disabled, and that's providing 1 meg, we've got 1.5 meg. But I suspect that the onboard RAM is disabled, and we've just got 1 meg here. So inside the can here, you've got your video shifter chip, I think. Yep, there it is. And it's normal for RAM modifications to tap some of the signals off there. It's quite common for that. A lot of the Marpet ones work that way. Let's just we'll leave that. I'm not going to twist that back. And as I say, the square chip here is the MMU. Your memory management unit, and you've got the 68,000 processor here. It looks like one of those ones with the super thin legs again. I found that on these ST boards, if you try and desolder these, it's really easy to damage them if you're not careful. The pins are like, I don't know why there's a difference, but if you get one that goes in a socket, you find the legs are really thick on it and they're really sturdy. But the ones, a lot of these STs, they're really, really thin. They've got like thin metal used for the legs. Not on all of them, but on the 1 or 2 I've looked at, that's been the case. So you can see we've got a space for the blitter here and a couple of jumpers, solder blob there, W3 and W4. I'm pretty sure those are related to the blitter, so you could fit a socket on there and fit a blitzer. That chip there is going to be the glue. It's glue logic, quite literally. Bus transceivers and stuff, probably like 245s and 373s or something like that around here. That's going to be for your MIDI. Is it an Opto or something there? Some standard 7.4 series stuff. Got your video encoder there, MC1377P, the same chip that is used on Amiga modulators and on other systems as well. That's probably the 1772, because I think 1772 is smaller. Yeah, I was right, that's the 1772, because yeah, it's not a 40 pin or anything like that. So I'm not sure what that is then. This is the 1772, that's an MC689C1P, and then you've got these ASIA chips here, some standard 74 series ICs, and actually that's a 1488 and that's a 1489, so you've got your serial receiver and transmitter, I forget which way around those go. So powering it on here, you can see the LED is lit. So just measuring the 5 volts there, we've got 4.94, and on the 12 we've got 11.46. So it's strange how this is just not doing anything. I mean, nothing at all, no video output. So the next thing we can do to quickly rule out whether it's a video problem or whether it's just not booting, you know, it's crashing or whatever, connect the floppy drive up. I've got a disc in, and you can see the LED here. And if you just listen, traffic might mask it out. There's no noise, nothing at all. It's not even attempting to look at the disk drive there. So I would suggest it's not even getting off the starting mark here, you know, it's not even booting up. So my guess here, it could be a bad connection on the MMU, but I'm not sure that that would result in not starting to boot at all. We'd see some video. I think more likely the shifter, but I think more probably the glue, actually. So I might need to order one of those because I don't think I've got one spare. I have got a spare shifter, but I think I've seen this before where the glue chip dies and you just get nothing. You get no video or anything. So what we can do is carefully unclip this. I forget how these work now. It's like hooked over the underneath of the socket, isn't it? There's probably a special tool you can, there you go, you can use to get these off, but it's like a clamp. There you go, and it's kind of spring loaded. I think I've got one of these somewhere that I took off my MMU on mine. It's kind of stuck over the edge there just a little bit. Hope we don't break the socket doing this. Come on off, you come. There we go. It flew off that there, and then this thing just sits over there like that. Again, it's kind of clipped on. There we are. So we can try and just remove and reseat this. I'm just going to ground myself. Should be wearing an ESD wrist strap, really. Doesn't feel like it's gripping very well, that. It's not. So it took a few attempts to get that out there. The chip looks okay, other than the couple of scratches I've put on the top of it with the PLCC extractor there. Just try and get that back in. But I suspect we may need to replace that chip anyway. I think that that's more likely than the shifter. But I do have a spare shifter, so we can try that. I think I might have one of these, but I think it's a faulty one. And the interesting thing is, it doesn't say RGB either. It just says X1 DVD. Normally, just if the blanking pin's set right, it will come up saying RGB. But we know it's not booting. That's the other thing. It's not like it's you know, just the video that's missing. So now we've scoped nothing here. So I've just taken that out. I did cheat. I did use a screwdriver just very carefully because the PLCC extractor was scratching the sides. It's proving very difficult to grip it. So you can see we've got a brand new glue chip there. Well, I'll say brand new. It's old stock that's been reclaimed. And we'll just carefully get that in the socket. Pin 1 is here. There's a little notch on the IC there. Just push that in, and what we'll do is just power it on, see if that fixes it. I've got a feeling that could be the issue, but it could be other things. We haven't scoped or checked anything other than voltages here. So I needed a spare glue anyway, so there's nothing lost. I think the only thing I do need is an MMU, so I'll order one of those later. 1, 2, 3, 4. So pin 10's up here, 11, 12, 13, 14, that's 15. You can see that, that's the clock. So if I just try and pull it off and put it back on, it's pulsing. So we've got a clock, and then you've got 15, 16, 17, 18 I think is reset. And it's high impedance. if I just power cycle it, you'll see it goes low for a reset, but never goes high. So it's like it's not coming out of reset. That's what's wrong with this, I think. So apologies, you can't really see very well because of the sun there. The reset circuit is around here. That's an NE556. So I think it's got two 555 timers in there, if memory serves. And there's a diode here. I thought I'll just check that. And it's shorted at 0.27 both directions. So I'm suspecting that diode might be the issue, actually. I need to have a look back at the schematics now to see what that diode does. I need to check everything else around here, see if anything else is shorted. But I suspect that diode's the issue. So just to rule it out, because I think maybe it could be the 556 here, I'm just going to remove it and socket it up. I've got a spare here. Incidentally, I think the spare came from Alison Chalice's spares, actually. So it's another one of these thanks to Alison. It's incredible. I think there's 4 or 5 things in the last month that I've taken spares from Alison's original collection. So thanks to Colin and Nathan for sending those. So as you can see, I heat that for a minute or two, and then I'm just removing it with the extractor here. I think it's free. Yeah, there we go. No damage. Be careful around batteries like that. I shouldn't really have that battery there. It's going in the bin anyway. It's completely failed, that battery. It's not holding any charge whatsoever. Anyway, that's another video. So we'll get socket on there. Yeah, that's looking fairly straight, that, so we'll solder the other pins. But yeah, the other thing that I thought of, and looking at the schematics, the Halt pin from the CPU goes into this as well. I can't help but wonder if when the CPU crashes, it causes a reset. But then again, why are we seeing a high impedance reset signal? That's the thing that doesn't seem to add up. So I think it kind of would point to this or a supporting component. Well, I measured the resistors and things and examined the caps around here. They seem okay, but you never know. Maybe one of these ceramics here has failed. We may need to take it off and measure it on my cap meter to determine that. I mean, obviously you could scope the various signals, the threshold and the various pins around there to see what's going on, the trigger, etc. Yeah, so it's in there. Let's go and give it a try, see if it's any different. I've got the ground level set down here. What I'll try and do is I'll film twice here, so I'll show you on the scope and show you where I'm measuring. So I'll start by just checking these crystals here. And if we just move that up a bit, you can see we're getting a nice sine wave there. And if we measure the 32 megahertz there, yeah, there you go, that's 32 megahertz. And we have another crystal up here, let's just check that. So the shifter here takes 32 megahertz in and divides out, divide by 2 and gives you 16 megahertz out on that pin there. And as you can see, that's okay. And it's a bit of a maze of things, this, because the 16 megahertz then goes into the MMU and then gets divided down again. I think you get the 8 megahertz out here for the CPU. I could be wrong, we'll check that in the schematics in a sec. And slower speed, is it 4? Well, it might output 4 and something else, I can't remember. But if we check, I think that's like 1, 2, 3, 4. I think the next one's pin 5. 5, yeah. And as you can see, we've got the clock there. So there are very few clues here as to what's going on. But if I scope the CPU pins, and it goes like 1, 2, 3, 4, 5, I think. 5 pins here. There might be 6, I can't quite remember now. And then the remaining data bits go up here. But I mean, I'll show you that separately. So if you look at that now, there's some crazy transitions here. You know, we've got different logic levels. As it's, there's something else on the bus there with a slightly different logic level. I mean, look at that. That's just crazy. Absolutely crazy. It's no wonder this is not booting. I think we've got something trying to output on the data bus when the CPU's trying to boot, like a conflict. I mean, look at that. That's another data bus pin. What is going on there? I don't know. It's a mess, isn't it? It shouldn't look like that, that's for sure. These are some of the other data bus pins here on the other side. Again, look at that, it's like 3 different levels. I don't really know what's going on there. Bear in mind, like I say, if we swap the shifter or the glue or the MMU, it's no different. So in terms of the temperature test, yeah, the CPU's, it's a little warm, not like boiling or anything. The MMU and the shifter are stone cold. The glue is stone cold. I mean, like it's not even powered. What's this here? This is the DMA. The DMA controller's cold. The AY chip there, very lukewarm, hardly anything at all. Nothing there. A little bit warm there. That's like the second warmest thing so far versus the CPU. You know, that's reasonably warm. And that one's like lukewarm. I wonder if one of these, I don't know whether these connect to the data bus. I'm just wondering if one of these is the issue. These are kind of like the CIAs you get on an Amiga. I think they're called an ACIA. We could scope some of the pins on those, I guess, just have a look. Yeah, so scoping one of those. What's this signal here? I don't know. Let me check on the other chip of the same pin. Yeah, same thing on both of them there, on the same pin. Anyway, the next pin along, that looks normal. That doesn't, kind of looks like the data bus again, doesn't it? With different levels there. I wonder if that's a data bus connection. I might just test that on continuity in a sec. And there, yeah, these are all looking, that's sort of looking better. But yeah, the strange transitions between logic levels here, look. I wonder if that ASIA is dead. I mean, it could be whatever's enabling it. You never know, there's like a little, is it an MCU type thing there? An MC689C1 or something, I don't know. It could be something to do with that. I don't know whether that controls the chip selects for it. I'm just looking at the other chip now. Same thing again. They are both kind of lukewarm. They are the second warmest thing on the board. You've got the CPU getting warm, fairly warm now, and then those two ACIAs, I can't even say them. ACIA. So, I don't know, maybe I should pull one of them. So I'm not 100% sure, but I think I see data bus connectivity between these and the CPU. Considering this is getting hot here, not like red hot, but hotter than anything else on the board, equally as hot as perhaps the CPU, and everything else is very cold. You know, the main custom chips are stone cold. I think it's not getting off the mark there, booting. I think the data bus is compromised. We've seen awful data bus signals there. I think I'm going to remove this. We'll see if that makes a difference. I may then remove that and see if we can get any further. I am assuming that we might at least get some initialization of the video. You know, we might get, because there's no, that's the thing I've not mentioned. I scoped it, I'm not showing it. H and V sync come out on here, somewhere on this side up here. It's like 39, I think it's blank, 38, 37 or 38, 37, 36. I think it is 3 pins there, H, V and blank. They're doing nothing, so I think maybe the video side is not being initialized. I'm guessing it's not kind of automatic. It's not like it automatically outputs H and V. I think this has to be initialized in order to output something there. You know, maybe put it in the right video mode or something. And the clocks are all alright, so it's not that. The power supply we checked right at the start. Yeah, let's remove that. So it's important to know there are other things you could do. For example, I have a diagnostics cartridge, and we'll show you that later. I've tried it. I haven't connected it via serial, but you know what? I don't think it's getting off the mark. I don't think it's booting at all. I think the data bus is compromised, so I think it would be a fruitless exercise me connecting it up to the serial port on the PC to see what is going on. There may be something that gets output there via serial before it fails, but I don't think so. I think the data bus is dead right from the offset here. The reset was a bit of a red herring at the start there. I don't know whether they explained, and I'll show you. I added a pull-up resistor. It seems like the version of board we've got here, they did away with a pull-up resistor. So the reset line changes between high impedance and low. And it may be that that's technically correct, and you can get away with that. I've just filled out the pin again, look. But nevertheless, I don't think there is a pull-up on here. So you will see it change between, let's say, high impedance and low. now it goes between low and high, which I think is better. So I think when I finish this, I will leave it with a pull-up on there. At the moment there's just one bodged on the underside, on the other side of the board. So I've removed most of the solder there. There's going to be the odd pin where on the other side of the board the solder has not freed up very well. I'm sure of it. If we just grab them, I've got a pin still soldered there. Look, I need to solder that one pin. Yeah, so it's this chip here, and you can see there's still quite a lot of solder on both sides. So yeah, I'm going to use hot air. So we're around 400 degrees here. There are these plastic posts and things here that you might want to get some Captain tape around, but we're not that close, so I think we'll be alright. I think we're almost there. I can feel the chip starting to move now. There you go, you can see one side has just come out. Yeah, look, very little is needed. I would say I've spent about 1.5 minutes, maybe 2 minutes at most on that. And of course you could heat from the other side. There you go, that's the chip out. So that made no difference whatsoever. I'm going to get a socket on. I'm not going to put the chip in just yet. I'm going to have a bit of a random direction change and go that way up the board and have a look at the 244s and 373s on the scope, I think. It's an old socket this, new old stock, so I've cleaned the pins up with a little bit of vinegar there. Anyway, I'll fit that now. If we don't get any further scoping things and trying to see if we can find any clues, then I will try connecting up via RS232, but I think it's going to reveal nothing, if I'm honest. A little bit of solder mask removed there, it's obviously covered with solder. Well, you know what they say about inspection. Inspection should be one of the first things you do, and you know what, I did have a quick look over this, and I couldn't see anything obvious. But having cleaned up this area here and then started to inspect around here, you can see some little scratches and things. This is from whoever worked on this in the past and upgraded it. But that just caught my eye, that dark solder point. Then I noticed there's 2 or 3 or 4 around here. Let me just put you on a macro. So I'm going to clean these up one at a time with the fiberglass pen. I bet it's one of these that's broken. That one could be a good candidate. It goes from 2 traces, look. And there's one there. So yeah, there's 4 or 5 of those just around that area. So you can see the little patches of rust there where I've used the fiberglass pen. Just going to go over these with some vinegar now. Collect up the bits of dust here. It could be another Occam's razor, the simplest explanation being the most likely. On this, I'll show you the port at the back there, super corroded the shield on it. That would have been a clue for anybody looking at this to go, hang on a minute, if we've got that level of corrosion there, we should thoroughly inspect everywhere, because maybe this has been stored in a damp location. I think that's the case. But it's really weird, like, the CPU pins down here, they're all spotless, everything's spotless. It's just some of the wire points down here. So, it's a little bit odd, and it's not got on a wider area either. I mean, it could be a multiple faults issue, this. You know, one thing that did cross my mind is I'm testing with the original glue now. So, let's say the glue failed and could have caused one of the 6850s, is that the right part number? I think it is, to fail there as well, or maybe something else. I don't know. I'm trying to remove the solder from there, look, with a bit of braid, and then we can refill those in a second. It'll allow me to inspect the traces for damage as well. So I see solder on the trace leading to the pad, and then I see a gap, and then I see the pad. So I think those have actually corroded over. There's a little spot here, I don't know whether you can see it, like a little bit of potential corrosion. Let me just get a bit of flux onto that. It's just like a bit where the solder mask's worn off, and corrosion has just got to the point there. Yeah, I'm not going to go crazy there because I'll end up tinning up everything. Does that make sense? You know, the solder mask will come off with a bit of heat, but I have just tinned up that little bit. So I think you could class this as a fault, maybe the fault. If we test that via there, so I'm on the wire, I'm on the trace, nothing. If I test from the trace to the trace, you can hear we've got a join, but on the via, nothing. So that one's faulty, but this one here is okay. Test on the other side, there's only a little bit of the pad exposed there, the trace rather. Yeah, so that one's okay. And this one down here, again, is okay. It turned up really well. So I'm just going to get a little piece of Kynar into that via and along this trace here, and inspect a bit further afield just in case there are any more of these. I'll be honest, I did examine this board fairly closely. I don't know how I missed those 4 points there. I think it's probably because I was looking at the actual chips and these traces. If your eyes are focusing on the things you want to see, you won't see other things, if that makes sense. I mean, it's still a bit dirty around it and it's cleaning, but anyway, let's just fix that, retry it and see if that makes any difference. I'll be curious to see where that goes. We can do some connectivity tests, I guess. I mean, it's going down to the blitzer here, which isn't even fitted, but ultimately it could be an address or data line that goes elsewhere, you know, via this point here. And the moment of truth. Yes, we have egg on my face, because I removed a 6850 that was, yeah, irrelevant. I think the thing is, from memory, when you scope the data buses and stuff on these, they look really horrendous. They really do. They don't look nice and clean. You know, you saw all the different logic levels sort of overlaid each other as it's transitioning between, you know, reading and writing to different chips there. That could confuse you, thinking the data bus is compromised when it perhaps isn't. And the fact that one of the 6850s, and it's missing at the moment, that's why we're getting that clicking. Keyboard's not connected, but as you can see, it's booting, so we fixed it. Yay! So you know what, I'm not too proud to admit, I don't always get everything right first time. You know, this is one of those ones where I ain't got a lot of experience with the, well I have, I've got lots of experience of fixing STs. Not where there's no video, no nothing, crazy behaviour. I'm guessing, actually, we may have had something on the diagnostics side of things, seeing what we've just seen, you know, that one connection broken. I'm guessing it was an address or data line. I can perhaps try and confirm that in a minute by measuring around and see where it goes. Anyway, just need to clean the solder off here and make sure the pins are nice and straight and flat, and then we'll get this back into the socket. We'll connect the keyboard up, connect the floppy drive up. We'll service the floppy drive while we're here anyway, and I've got some more ST floppy drives that I want to look at. So all is not lost. The other advantage, actually, thinking ahead, the fact that this is socketed, as I mentioned earlier, I've got no spare of these chip. This is the, you know, only the ones that are on here, the ones I've got. Don't have any spares. So I've been meaning to get some spares for a while. Let's just get a bit of flux on there. So I'm having to do a bit of scratchy type clean on these. Can you see the tip there? Look at that tip of that pen. It's black. So yeah, I'm using the EEV blog ruler here. It's upside down, just to get a little bit of support under those pins. Yeah, they're coming up a lot cleaner actually. And I cleaned the inside, as I've shown you before, like that. Tend to find they don't move when they've got a bit of pressure, like that, downwards onto a piece of paper. And then the final thing is just to clean this up with a bit of IPA here, and then we can stick it in the socket and go and test it. So I've got the ESD wrist strap on here. Let's get this chip into its socket. Just alternating a little bit here just to make sure the pins are, there we go, pins are okay, so that's in there. Let's connect up power and video again. You have to be careful when you're working on it like this, because you know you can kill yourself on that power supply. So I'm still doing the same thing, obviously with the noise there, that's common. Let me just hang on, take my wrist strap off before I trip up over something with it. And we'll connect the keyboard up. Yeah, when the keyboard's not connected, that clicking noise is exactly what you will get. So let's try that again with the keyboard. Yay! And if I press a key, you can hear keyboard's working. So that should come up the desktop. Great, nice clear display as well. There's a bit of a shadow on it, I don't know if you can see just on the side of the cursor there, it's a bit of a shadow. Anyway, let's switch that off. I'll connect the floppy drive up. So if you keep an eye on the floppy LED there, hopefully we should see something. There we go. So it tried that, it gave up. Let's try it again. And I think it's given up. So let me get an ST disc out. I tell you what, the interesting thing is, it's really persistent. It's like, maybe because the alignment's not the same or something, in terms of the sectors per track, but that took ages for that to give up. But the nice thing is we've got an A icon there, so it is detecting the drives. Try to boot from the drive, switch it off. I'll stick in my crusty copy of Pac-Land here, and we'll power it back on and see if it'll boot that up. We'll service the floppy drive in a minute anyway. I think that's booting. No, it's not, it's bombed. Now that could be down to RAM. Bear in mind this has got a load of RAM missing at the moment, hasn't it? Now I'm not sure if the upgrade added 1 meg or replaced the onboard RAM. Can you see that? So it could be something to do with that. Because I do know normally when you leave the RAM on here, you normally have to do something here with these, like feed it low or high somewhere in order to inhibit, disable the onboard RAM. So I'm guessing that we could have a fault there, but it might be that that's disabled via the mod that goes on here somehow. I don't think so though, because normally let's say you've got to do something with the resistors. Anyway, let's fit this again. Super fiddly getting these on. Be better off cutting off that glue there. What you've got to try and do is get it lined totally on the edge of those pins there. It kind of goes on the square side of the thing there. It's very fiddly. I might have to do this off camera actually. So just the same with that RAM in place. I'm not even sure if it's properly on there. These are really hard to get on. I'm trying a different disc now. Let's try Xenon 2. Because it could just be either a bad disc or a dirty drive there. Yeah, look, it's got the boot set thing there, no worries. So press space to dive. Wow, that's fast loading. I can hear the drive go. Wow, it works. Sweet. Sounds fantastic. Yeah, I'd say that's a success. That's working. I might just connect the diagnostic cartridge up because I think you can do various tests with that. We can test the RAM, I think, using that. So let's do that, because I have no idea how much RAM there is in here at the moment. We've got the 1 meg added. Is that giving us 1.5 meg, or is it just giving us 1 meg? So the diagnostics cartridge just goes in the side here, like that. So I appreciate it's quite hard to see this. You're not going to be able to see everything. When you do the RAM test, it reports 1 meg OK. So we've got 1 meg. It seems to be disabled in the onboard half meg. And if we do audio, I'll show you some of these tests. So you just get a low to high sweep on each channel there. Those all work, and the screen goes green if it passes the test OK. So we'll do T for timers. So that's an MFP glue timing video. That's the test it does initially. And if I just scroll across there, you can see it says pass. So they all do the same thing there in terms of showing a green screen with your pass or fail, or it goes red, I think, if there's an error. What else we got? We can't test the serial port. We can press C for colour, I guess. There we go, I've got some colour bars, look. All looks okay. Printer and joystick ports, got nothing connected to the joystick ports at the moment. H high resolution, you need a high res monitor to do that. Floppy disk, it's probably a destructive test. You probably need a blank format disk or something in there. Hard disk write read, I'm not going to do that. We haven't got a real-time clock. I think in general we're alright. The keyboard we could test, we could press K, and then I'm guessing it's going to give us an indication there of which key has been pressed, so I could do that. I'll report back in a sec. Yeah, that asterisk there is not very clever. We'll clean that up when we go in there in a minute. Every other key is okay. I can obviously reheat this glue here to hold that back in place there. Something to point out, can you see this post here? Look, it's wobbling. I don't think that's been epoxied back in. It's someone's used hot glue or something, look. It's like a rubbery glue. I don't think that's been epoxied on there. Yeah, it's kind of like hot glue, look, I think. So we need to epoxy this case back together. hot glue is it's not going to hold that on there. So it's been an awful long time since I've been in one of these. You've got a small screw there, 2 screws here, and then this pulls off. So I'll replace that tape in a minute. I don't know what Epson were thinking at doing it that way. Obviously, when you remove those screws there, this bottom piece here comes out really easy, so it's probably a good idea just to screw that back in while you work on the drive. It is really dusty. I can feel lots of dirt and dust in my hands here. So whilst working on this drive, it's worth pointing out that there are different types of drives in ST. You can't lift this, can you see that? You can't lift this very far, so you've got to be really careful when you're cleaning the heads on these Epson drives. Yeah, there are single-sided drives. They've got a single head. In the earlier STs, you might get one of those in like a standard ST or an STF. By the time you got onto the STFM, they tended to mostly, well, nearly all, I think, were double-sided. So you've got 2 heads there. And of course, that halves your capacity. So if you had one of those early drives, you had 360k on a single side of a disc. And you couldn't flip the disc over. You can see the dirt. Can you see that's dirt? The dirt's just come off that, actually. So the heads were pretty dirty. So we'll clean the rail up here. We'll get some molly coats on there. How does this one move? Oh, it's one of those. It's on a ribbon or something, isn't it? It's easy to push and pull, look. So you can wipe pretty easy around there. There are some through-hole caps, so you might want to consider swapping those out if a drive is still not working after having cleaned up all the various mechanical parts to this. Get a cotton bud down there so we can get right into that gap. And obviously, clean the wider area here as well. There's a bit of corrosion, can you see? It suffered some corrosion and stuff around the outside of this. But if we get cotton bud in here and clean in here as well. Your track zero sensor is right back there at the back of the drive, so you can either blow some compressed air or just give it a like that. That will usually do the job. So that's the synthetic grease I use, Molykote M30L. If we get a little bit onto the rail here, bear in mind, as you move that, you can distribute it that way, look. So it's pretty easy to do that and then get off the excess, because what you don't want is tons of excess in here. So I think that should do the trick. There's just a little bit on there. We can do the same thing with that little bit down there. Let's just get that into there like that, that's it, and then slide that up and down. There we go. And there are 2 sides to this, sometimes you may want to get some on the other side there. I'm trying to see what that, oh, I see. It's there, isn't it? It's like a little gear in a thing. Can you see this? Here. That's where it actually moves it. There's a motor. Just get a bit of grease there and do that. Wipe that off. There you go, you can see it rotating, look, a little bit of grease on the end there. You just want to get it to work its way inside that cavity, really. Let's just get a bit more, or a lot more. Try and squash it in there. And then just clean off the excess. So I think that's it for the inside of this. I'll reassemble this and we'll go and give it a try. The other thing to consider is the mechanical parts of this, the physical mechanism. As you put the disc in, it kind of lowers. Can you see that? And it's not that great on here, actually. So I'll just quickly show you where I've put grease. I've put grease into any of these little bits like that and move. Can you see? There is some movement here. And obviously, the bits around here as well. And on both this side and that side here, on the inside, because those move. Can you see that? They go up and down. And the same thing around here, squeezed some grease into there. So, yeah, it just feels a lot better. The discs go in and out better now. And so I'll stick a fresh piece of tape on there in a sec. I'm just cleaning it up with a bit of IPA. If we get the remnants of the old tape off first, and then I'll stick some fresh down. So that was a mistake. You don't need to remove that. It's a long time since I've been inside one of these. I do remember, though, I have done this before, because I can distinctly remember cleaning it up like this and sticking a fresh piece of tape on it. So just testing the drive again after doing that clean-up work. We're testing with Packland here. Now this disc was not working at all, so I'll be interested to see if that works. It's usually bombed by, yeah, it's usually bombed by then. So that's it. That's all that was wrong with that disc. The first disc we tested. It was something to do with the heads on the disc, I think, being dirty. Sweet. So be very careful when doing something like this. If you don't know what you're doing, don't go near it, because you know, you get rectified mains DC in one or two of these caps here. You know, 300 volts ish, 337 ish, I think it is. It's 240 times 1.414 recurring. If you've switched it off and on after you've disconnected the power, in theory it may have discharged it. There may be a bleed resistor across it, but sometimes not. So yeah, be very careful when lifting the board up like this here. Let's just flip that way, and if I can find these caps, where are they? I think there's one here. Let's just measure across that. Yeah, there's nothing on that one, and there's one here. You can see that 0.2 volts. So they're pretty well drained, but you could use a plastic handled tool like this to just short across those. I think that's one there, isn't it? Yeah, they're drained. Yeah, and those are the mains ones. You can see it's got a hazard sticker on it, so it's that one, and I think that one holds quite high voltage. Oh, no, it doesn't. That's a, or is it? Can't see what voltage that is. Is it 350 volts? Yeah, so just be mindful and careful. So having made sure we're not going to electrocute ourselves here, what we'll do next is remove one or two of these here, one by one, and these here. Just test them on the cat meter and test them on the ESR meter as well. So we'll start with the beefy 4700 microfarad one there. Can't see where the other leg of that is. Is it that? Cannot be that. It's not very long if it is. I think it's that one there actually. There may well be a tiny bit of glue holding these down as well, you know, some like rubberized stuff. Let's just see if we can get that off. Yeah, there we go. So the negative was towards the edge of the board there. So I think rather than use my other capacitance meter, we'll test it on the Atlas here, because this is going to show us the microfarad rating and the ESR at the same time. So if we just clip that on and give it a second. Yeah, so ESR is really good. Look at that, 0.02. It takes a while to measure. There you go, 5,898. So it's well above the 4,700. But the ESR is fine. That's the key here. That's what I was wanting to check. It's almost a short look. That's really good. So I think we can avoid skipping. You know, we can skip replacing that one. Let's move on to the others. So far, these were all looking okay, so I got the 100 out. Now this one nearly always needs replacing, to my knowledge. You see there, 0.29? That's a bit higher, actually. Now that might be correct for its voltage rating, 25 volts, but I don't think so, because all these other ones are like 0.6. Oh, 0.6, that is. So if we take that out of there, and I'll show you these 330s, there are three of them, and they measure identically. Look, 0.06, can you see that? And they all measure that way, so I think the 330s are fine. I think it's just that one there that generally always needs replacing, that 100. Again, 0.06. So I'm going to reinstall those three 330s, and we'll replace that 100. You could argue replace them all while you're here. See, that one's a bit higher there, 0.07, but I can try it again. I bet it comes out 0.06. There you go, 0.06. So they're all alright. I'll compare those to brand new 330s. So I could change those 330s. I've got some slightly low voltage, 25 volt here. These are Panasonic ones, I think. Let's just check one of those, see what that comes up at. Yeah, 0.42. That's even worse, actually. Yeah, that's even worse. I'm wondering if that is a Panasonic now. It might not be. I think it is. It's a M series, isn't it? Panasonic. So I actually think the ones that are there are better than the ones I would be putting in. This is the thing, so don't always just replace every single cap. If you can, get a meter and test them before you swap them out. Let's see if we can find it at 100. So let's test this one here. I think this might be an Avery or something. I'll see if I've got a Panasonic. Yeah, 0.64, that's even higher. So maybe that 100 is okay. Yeah, you see that one's another 100. It's a bit lower. It's almost like the other one actually. The other one was like 0.28 or something, was it? It's 0.24. That's a brand new one. So even that 100 is not necessarily needing replacing. Yeah, there's very little in it. So I haven't found anything wrong with this at all. Can you see that leg there? Any long legs like that, trim that off. That's like a transistor or something right in the middle of a couple of other pins there. It could easily get knocked across or something at some point in future. Just expecting around here for dry solder points and things, but it's looking alright. I'll clean up in a minute with IPA, where I've resoldered the caps. I'll just finish testing the last few. So the high voltage one here, it's 33 microfarad. Even that's coming out okay. That's about right. 0.43 for 350 volt cap is pretty normal. And the other one is the same there, spec'd the same, 350 volts, 33 microfarads, 0.36. Yeah, so my recommendation to you is perhaps swap them anyway, but you don't always need to. And the final one here, one of the 2200 on the secondary side, look at that, it's really good ESR, 0.02. Yeah, 2892 microfarads, so it's reporting a capacity over its value, even including its tolerance. But you know what, more smooth there is better than less. Some people uprate them. I think I uprated the ones in my ST power supply. So what I mean by that is these 330s you could uprate to 470s. This 2200 you could uprate to, I don't know, 3300 or 4700. And the 4700 either replace it with another 4700 or maybe go 6800 or something like that. But generally, the higher, slightly higher capacity you go on here, you'll just get slightly better smoothing. But anyway, that's my recommendation. Just for good measure now, I'm just going to reflow around the pins on the transformer actually. Not all of them need doing, there's just a few there that don't look great, so why not reflow them anyway. And then I'll just give it a quick clean with the cotton bud and we'll reassemble it. Just watch you don't get fibres stuck on this. You can see it's looking a bit dirty down here as well though. I think we'll clean this up. So I'll give the isolator wipe down here as well. And you know what? My highest recommendation for these is to replace this power supply completely. You can get a brand new one that's been designed and manufactured by Exos. I'll post some links down below. At some point I will show one on my channel. I just haven't had the funds to be able to order one of those. But it's a new PCB with a much better, more efficient design. It's got a toroidal transformer on it and everything. You literally just desolder the connections to the board and solder them onto the new board. You've got to use your own switch effectively, but it should just fit in place of the original. So I'll show you the underside of this in a minute where I fixed that trace. You can see the little solder blob there. That is where it corresponds on this side. And actually we've got 10, 11, 12, 13, 14 clock, 16, 17, 18. It's the reset. So I think this explains why I went off on a crusade looking at the reset to start with. And I suspect that the resistor I've added on the underside, if I remove that now, we might see this go high again, because I suspect that the resistor's perhaps somewhere up that side of the board actually. So that was the mod I did temporarily just to pull the reset line high. But I'm suspecting this is now doubling up, and when I say doubling up, it's actually kind of halving, because this is going to be in parallel to the other 1K, so you're going to have less than a K, it's going to be half a K. Anyway, let's just remove that resistor, and I can clean up the solder points. Let's just clean up around the 555, well it's 556 isn't it? Anyway, I think we'll try and get this off next, this label. I'll just try and peel up what I can, and then get the IPA onto that. I remembered something. From the schematics it was saying RP1 is where the pull-up resistor goes for the reset, and that's all the way up here. You can see it here. So I thought that's a really weird place when the 556 is right over the other side of the board. But and I did a continuity test and I couldn't find a connection. But I thought, well, maybe it's just this revision. This is a different one. It's got the resistor packs here for something else, and RP1 isn't the same as on the other schematics. But actually, one probe on the reset over there, you'll hear we have a short. Dead short, 0 ohms. So that's the pull-up for the reset line. There we go, that's that mark gone from there. Just need to do the same with this now. This has got something sticky on top of it there, look. I'll clean around here with cotton buds in a sec, but we need to deal with this light corrosion on the top of the, I think it's the serial port, isn't it, the modem port. So a little bit of repair there, and the few that I just reflowed here, I put a little bit of green nail polish. You can see it's almost the same colour as the solder mask here. And whoever scratched the traces there previously, I covered that as well. It's like several of them scratched. You can see some scratching there, can you see that in the middle? But I'm not worried about that, it's on the ground plane. I think other than the crazy flux, can you see here, on all the ports, which is typical with one of these, you know, they're all like that. You know, you can see even the floppy IDC connector. Some components there around the modulator, those would have been soldered that way at factory, and the video connector. I'm not going to clean that off, it's going to be fine with that. Other than that, I think this board is very good now, is ready to go back in the case of stuff. Yeah, just retesting the reset here, I'll show you. If I press reset, do you see it go high? Yes, it goes low when you hold it, and when you let go, it goes high. So yeah, that was the clue actually. What I should have done is, the point when I noticed it wasn't going high, I should have dug around more and tried to find the resistor. What I ended up doing was putting my own resistor on there. We had the reset working properly, still wasn't booing, and then I went away looking at other things, you know, started scoping things and thinking that because one of the CIAs over there was getting warm, that maybe that was something to do with it. So that was where that post came off before, and it is just hot glue, it isn't epoxy. With a bit of IPA that'll just come off. I can show you better on that post there, can you see at the edge there? Just watch, look at that, it just pulls straight off, it's just hot glue. So he's done a good job of reassembling it and it holding together with the hot glue there, but with any kind of movement or anything, the hot glue will just come straight off. You've got to use epoxy or something similar. This bit has been hot glued here as well, and there's a break there which hasn't been fixed. That one's been hot glued on, so I'll remove the hot glue and stick that one back down. And on the inside of the lid here, it's the same thing, hot glue, a big stretch of hot glue there, so again I'm going to have to remove that and put epoxy on it. So all my case parts have dried. I got epoxy in place of the hot glue here, around that post there, hopefully that's nice and straight. And then various points here, you can see there were various bits broken off. Some of them were stuck with hot glue, so let's say I removed the hot glue and then restuck them down, and we had a big crack there, so that's all in one piece now. And on the top piece I reeded those with epoxy. I left that piece there along the back. It was a really long strip with hot glue. That would have been really difficult to remove all that hot glue, but it's holding in place, so I think that'll be okay. I did, however, stick that back down because I found that floating around inside the case there, piece of plastic from there. So the next thing we'll do is start to reassemble it. We'll get all the shielding and stuff in place. So we've got the bottom piece that goes here, I think. We'll get the board into that, like that. We'll get the hot air on this, 150 degrees, see if that'll remelt and join there. You can just see how much those pins protrude. That's correct, that's in as far as it will go. And the glue is meeting there where it originally was joined. And it's the same down there, can you see that? It's joining back up, so I just need to heat it. Yeah, so I think that's melting. It's hard to tell. Yeah, it's kind of going glossy, look. Yeah, that should do. Can you see that bit's joined back up? And it's the same down there. Can you see that's all joined back up again as well? So I feel comfortable that that should hold when it's in transit, this. when you're putting this back together, there's absolutely no point in twisting those metal twists all the way around, because there is so many screws. I'm going to give you an example down here. Can you see that? We've got a metal twist. What is the point in twisting that when there's actually a screw that goes through here and pulls the two pieces of shielding together? They'll break off eventually anyway. It's just pointless. I don't even know why they put them on it, to be fair. Something else that may help you, there are two different sizes of these screws. One's slightly longer, and the longer one goes through where you've got a brass mount on the underside. So on this one, there's a brass mount there, there's one there, and the points where the power supply held in, the two that are underneath there, those are all the slightly longer one. They're about sort of that length, whereas the other ones are a little bit shorter. So the shorter ones go through the bits where there's no gold, copper coloured thing on the underside. It's just shielding to shielding. So you have a shorter screw, and there's quite a few. Like that's a shorter one, that's a shorter one, that's a shorter one, that. There's two underneath the drive there that hold the shield as well, and obviously here and here as well, and down here. So the serial port we cleaned up there. Can you see it's looking a bit oxidised on top? Well, what I do have is the dongle here from the Amiga. It's a loop back, and if I switch it on with a diagnostic cartridge in, now it's on RGB, you can see it's much clearer there. And if I do S for serial port, we get a bill of good health there. You can see at the top right here it says pass, and the screen is green. What I can't do at the moment is use the parallel dongle here, because I believe the one on the ST is different. It connects to the joystick ports, so you can test the joystick ports via the parallel port. It's some sort of harness that connects to the parallel port with a cable coming off that goes into the joystick ports, I think. So the keyboard will follow this video fairly soon. I'm not going to cover it in this video because we've done enough in this video, but there is a common issue with the keyboard here. I'll just show you. Hang on. So the common issue with this is the solder points on the ports here crack. It's very, very common. I've had to do this on every single ST I've ever come across. Now this one seems alright, the ports seem alright. Be interested when we have a look at this in another video to see if the points are actually started to crack or fatigue on the underside of those. It's because they're at 90 degrees, and it's because of the way the cables plug in on the underside there that these get a lot of stress on them as you're pushing them in and stuff. And the other thing we'll cover in that video is any of the keys that aren't working. You can deal with that as well. There are long screws, as you can see, and short screws, and the short ones, 3 of them, go along the front edge here, holding the front of the case on, and the longer ones go at the back. As I say, I think we're one short. The one under the warranty seal seems to be missing, but it's not that important as long as there are at least 3. You've got the one there, one here will stick in. But I found replacements and put the screwdriver in and just levered it like that to straighten the pillar on the inside, and the screw's gone in okay, so it's complete now. Sweet. Yeah, so you can see it's a bit slow, but I prefer it like that because it's more playable. Sweet. You can see in a previous video how I fixed the SCART cable. Actually, it was brand new, but it wasn't displaying in RGB mode on my TV. It was using composite. It looked awful. So I didn't show you me cleaning up the keyboard and cleaning up the case. I got all the mucky marks and stuff off it. It's come out really well. You can see some keys are more yellowed than others, but you know what? That is in very good condition, really. The only downside from the outside is you can see where the little things were split here on the case. Those are the only two bits that are really visible from the outside. But in general, I think it's come out really well. So I'd like to give a thanks to this chap up here who donated this to the channel. I am much appreciative of that. It's given me some interesting things to do here. You know, we've had two or three different videos related to the ST here because of this. So yeah, it's been great looking at it. And before I forget, we landed on the reset problem fairly early on. Well, I started looking at the glue, didn't I, ultimately. I think the issue was the glue in terms of the reset signal. The reset signal wasn't getting across to that, you know, the pull down. But that also meant it wasn't getting to things at this side of the board here, where the glue chip is, where the that little MC, you know, it's like an MCU, isn't it, or something for the serial and parallel comms and stuff. It sits around that area of the board. One of the ACIAs was getting hot. I think it's because that area of the board had not been reset. The glue hadn't been reset. That's why we're getting no H and V. I think that area of the board was completely dormant, maybe outputting highs on some of its connections, which is typically what will happen. The Motorola CPU on these, I think, outputs all highs until it's been reset. So that's probably why we had a data bus conflict at that point. So I'm glad I did spot that little bit of corrosion, because that's the sort of thing where I could have gone around for hours and hours and hours with. Anyway, I do hope you found the video interesting. So without donations like this to the channel and the Patreon support, I wouldn't be able to financially afford to keep running the channel. So thank you very much to everybody who supports me. Thanks for watching, thanks for subscribing, thanks for your comments. Give us a thumbs up if you can, or a thumb down if you don't like it, and I'll catch you in the next video.